How many physical CPUs does my machine have? I am a bit confused about the number of CPUs my server has. It is running on Intel Xeon, a Gold 6242, a CPU at 3.10 GHz, which according to official Intel docs contains 20 physical cores. The problem here is the output of LSPU command, some rows filtered. From what I understand, actual physical cores equals CPUs, threads per core, but then I get 40, which is double of what I expect. Can someone please explain me what is going on here and what exactly CPUs, threads per core, cores per socket, sets mean?
Sockets represents how many physical cores are in the system. Cores per socket is how many full CPU cores, including loading/decoding logic, there are per physical CPU. Threads per core is how many threads can be scheduled on a single core, hyperthreading. Simply said, the hardware in the CPU that is used before the actual execution of code is doubled, allowing the CPU to have multiple different tasks ready for execution. It allows the CPU to fetch/decode instructions before they hit the execution core of the CPU. It prevents or reduces pipeline stall. CPU means schedulable entities. This is how many run queues the operating system will have, so that would be sockets x cores per socket x threads per core. In your case, you have two physical cores, which each have 20 cores, which each can run 2 threads, hyperthreading. So, 2 by 20 by 2 equals 80, which is the number of cores displayed.
The confusion comes from a very simple detail that might be unclear from the info LSPU command is showing you. The thing is, your server actually has 2 Intel Xeon or Gold 6242 or CPUs, which is mentioned in the sockets row. As the Intel documentation states, each one of those cores contains 20 physical cores, the cores per socket line, which gives a total of 40 physical cores. Each one of those cores is able to run 2 threads simultaneously, the threads per core line. So, 2 Intel Xeon, 20 physical cores each one, 2 threads each core, gives a total of 80 units that can execute a process or cores.
The idea of a CPU is a bit of an abstraction now, and this started with hyperthreading, late 90s, and then the Intel Core, early 00s, series. Before then you definitely had multiple CPU systems, but they were all multiple physical CPU. But with hyperthreading and multiple core single PIS, the physical hash of PIS is different than the logical hash of PIS, the running code on the PICs. You have 2 physical PIS as in thing with heatsink plugged into your motherboard. Each physical CPU has 20 cores, which look and mostly work like independent PIS to Linux. Cores share at least the same L3 cache, probably L2 cache, and probably have their own L1 cache, so not quite as performant as individual sockets with their own L3/L2/L1, but nearly there. Since that's each socket, you have 2 times 20 equals 40. Each core has 2 SMT threads, which are implemented by your CPU's microarchitecture to basically look mostly like independent PIS to Linux. They're not going to be anywhere as fast as real independent cores. Threads on the microarchitecture try to grab currently unused pipeline stages from cores, but might have to end up waiting if busy, and PIS already try to keep themselves very busy. So again, 2 threads on 2 cores is nowhere near equivalent to 4 cores, but it is something that can make code run a bit faster. Note that Spectre and similar vulnerabilities are much more possible across threads than cores or sockets because core resources are shared. Anyway, since that's per core, and also per socket, that's 2 times 20 times 2, which gives you
Dual CPU, processors X2, 20 cores per socket, X2 equals 40 cores equals 80 with height. This is probably very easy to verify by simply taking the lid/side off.
If you want to level up your program, these are